Now we are in the hangar of the Dolgoprudny Design Bureau of Automation and are conducting factory tests of our shell. This is the gas shell of the stratostat, which we hope will make its first flight this weekend. Factory tests are necessary in order to check the quality of the manufactured shell and to verify the calculation methods that were used in order to make such a shell subsequently. That is, when we fill this balloon with air like this, we check the strength of the seams, we check the geometry, and we check the welding techniques that were applied when the shell was manufactured in our production. The shell was manufactured on behalf of Nova. And the Nova company shows quite a lot of interest in aeronautical engineering and stratospheric airships. At the facilities of Bauman Moscow State Technical University, the shell was manufactured, the one which we are now testing. We are conducting factory tests of the shell, factory tests by the method of its filling with air. We are conducting a study of the tightness and strength of the shell. We turn the shell upside down and fill it with air. That is an ordinary blower that fills the shell with air through a hose. Such an operation is necessary in order to test the strength characteristics of this shell. Filling with air in this inverted state simulates the same loads that would be in the same balloon, in the same shell, in the event that we filled it with lift gas. So far so good. The volume of the shell is about 2,000 cubic meters. We have to fill a volume of 2,000 cubes, and after this 2,000 cubic meters of air are put inside the shell of ours, it will experience all the same stresses that it will experience during its flight. So, if it can withstand being filled with air here in our hangar, then we can safely say that it will withstand all the stresses that it has to experience during its flight. The shell is made of film. It's made of a special film that holds the gas well. This is not ordinary polyethylene. It has a special layer added to it that holds the lift gas well. The lift gas will be helium for the flight. There is a relationship between the mass of the payload that can be lifted by such a balloon and such a shell and the height to which it lifts that mass or that payload. We want to fly to an altitude of about 24 to 21 kilometers. So, this 2,000 cubic meters shell can only take 10 kilograms of payload to that altitude. 10 kilograms of payload and 16 kilograms of our ballast shell, which will balance and facilitate the normal flight of this whole structure. This shell is one of the elements of stratospheric maneuvering platforms that will allow to perform the tasks of atmospheric satellites. They will be able to stay constantly at altitude, to transmit information, to monitor, to perform scientific research. This complex structure is made in order to test the technologies that it is possible to do and that can be applied to the conditions of monitoring, to the conditions of relaying communications. And we want to test, first of all, the technologies of manufacturing, and as you can see, the technologies of testing, factory testing of such shells. This work is done as part of our cooperation, our collaboration with Nova. And we are very grateful to Nova for sort of developing this kind of interesting area. And I think it's a very necessary area that can be useful for the economy of the whole country and maybe not only our country.